পর্যন্ত, যেটা ছিল আমাদের ফ্লো কন্ট্রোল। তো রেসপন্সিবিলিটির মধ্যে হয়তোবা তোমাদের খেয়াল আছে, সেটা হচ্ছে আমাদের রেসপন্সিবিলিটির মধ্যে প্রথম ছিল ফ্রেমিং করা, ঠিক আছে, ফ্রেমিং করা। দ্বিতীয় কাজ ছিল হপ টু হপ ডেলিভারি করা, তৃতীয় কাজ ছিল ফ্লো কন্ট্রোল করা, চতুর্থ কাজ ছিল এরর কন্ট্রোল। এবং এই এরর কন্ট্রোলের 3টা মেথড আছে। এই মেথডগুলোর উপর ভিডিও আমরা একটা দেখবো আজকে। আচ্ছা, এরর কন্ট্রোল কেন দরকার? কারণ হচ্ছে আনওয়ান্টেড ডেটা রিসিভার এন্ডে পৌঁছে যেতে পারে, আবার অনেক সময় এক্সপেক্টেড ডেটা পৌঁছাতে না পারে। তো সেই জন্যই এখানে আমাদের যে জিনিসটা দরকার সেই কিছু টেকনিক আছে। ওকে, আচ্ছা, তারপরে হচ্ছে ফিজিক্যাল অ্যাড্রেসিং অথবা ম্যাক অ্যাড্রেসিং করে এবং অ্যাক্সেস কন্ট্রোল করে। তো এরর কন্ট্রোলটাই পর্যন্ত আমরা পড়বো। এই দুইটা সবসময় খেয়াল রাখবা, এই দুই অংশটা এটা অপশনালের মধ্যে, মানে যদি জিজ্ঞেস করা হয় অ্যাটলিস্ট মেনশন 5 টেকনিক তোমরা বা 4 টেকনিক, এই পর্যন্ত থামলেই চলবে। অ্যাক্সেস কন্ট্রোল এবং ফিজিক্যাল অ্যাড্রেসিং এটা হচ্ছে বাই ডিফল্ট ডেটা লিঙ্ক লেয়ারের মানে রেসপন্সিবিলিটির মধ্যে পড়ে যায়। এটা নিয়ে আমাদের কোনো মাথা ঘামানোর দরকার নেই, কারণ হচ্ছে ম্যাক অ্যাড্রেস জেনারেট করে ম্যানুফ্যাকচারাররা। তো আমরা ম্যানুফ্যাকচারার হিসেবে আমরা ওই এন্ডে যাচ্ছি না, আমরা ডেটা নেটওয়ার্ক হিসেবে, ইঞ্জিনিয়ার হিসেবে উই আর গোয়িং টু প্রোগ্রেস। সো ম্যানুফ্যাকচারার হিসেবে যদি ম্যানুফ্যাকচারার ডেল কোম্পানিতে যদি জব করতে যাও অ্যাজ এন ইঞ্জিনিয়ার বা অন্য কোনো ম্যানুফ্যাকচারার হুয়াই হতে পারে, ম্যাক অ্যাড্রেসিং সম্পর্কে তখন আইডিয়া বেশি পাওয়া যাবে আর কি। তবু ম্যাক অ্যাড্রেসের উপর একটা ভিডিও আমি প্লে করব। আচ্ছা আচ্ছা, সিঙ্গেল বিট, প্যারিটি বিট কি, এগুলা কি? অডিও কল, ঠিক আছে, অডিও কলে ডেটা কমিউনিকেশন হ্যাজ সিঙ্গেল বিট এরর। হতে পারে কি আমরা m+1 বিট এক্সট্রা একটা কোড ওয়ার্ড তোমার ইউজ করি। এমটা কি? আমার হচ্ছে মেসেজ, আমি হ্যালো বললাম, হ্যালোর সাথে আমার একটা এক্সট্রা বিট চাই, যাতে এক্সট্রা বিটটা কি করে, এনার্জাইজ করে, ঠিক আছে, আমার মূল মেসেজকে এনার্জাইজ করে। এতে কি লাভ হয় স্যার? আমার যাতে আমার যে মেসেজটা সেটা গিয়ে যাতে পৌঁছে, সেটাই এনশিওর করে। তো এখানে ইভেন প্যারিটি, অড প্যারিটির কথা আছে। ইভেন প্যারিটিতে বলা হয় নাম্বার অফ ওয়ান্স শুড বি ইভেন, আর অড প্যারিটিতে বলা হয় নাম্বার অফ ওয়ান্স শুড বি অড। সাপোজ এখানে কি বলা হচ্ছে দেখো, সাপোজ উই আর সেন্ডিং 1010, আমার মেসেজটা হচ্ছে এটা। সো ফর ইভেন প্যারিটি উই উইল অ্যাড এই যে 1010 এর সাথে লাস্টে একটা 0 অ্যাড করব ইভেন প্যারিটির জন্য, কারণ এখানে অলরেডি দুইটা 1 আছে। ইভেন প্যারিটির জন্য দুইটা 1 থাকলে আমরা আর কোনো 1 অ্যাড করব না, আমরা একটা এক্সট্রা বিট হিসেবে 0 অ্যাড করব, বিকজ ইভেন নাম্বারস আর 1 আর দেয়ার। সো বিকজ আর ইফ উই সেন্ড মেসেজ যদি আমার 1110 থাকতো, তাহলে আমরা একটা এক্সট্রা 1 অ্যাড করতাম ইভেন প্যারিটির জন্য। জিনিসটা আবার উল্টিয়ে যায় হচ্ছে অড প্যারিটির জন্য। তাহলে স্যার আমরা ইভেন প্যারিটি কখন ইউজ করব? অড প্যারিটি ইউজ করব। 90% কেসে আমরা ইভেন প্যারিটি ইউজ করি, অড প্যারিটি না, ঠিক আছে। ইভেন প্যারিটি, সবাই এখন ইভেন প্যারিটি ইউজ করে, ঠিক আছে। আচ্ছা, তো ক্যান ডিটেক্ট অল সিঙ্গেল বিট এররস ইন কোড ওয়ার্ড m+1, এটা হচ্ছে সিঙ্গেল প্যারিটি বিট, যেটা বললাম আমরা, যেটা পড়লাম সিঙ্গেল প্যারিটি বিট টেকনিক। আর এটা আরেকটা কাজ করতে পারে, ক্যান ডিটেক্ট অল odd number of 1357 length errors also. এটা কি করতে পারে? ডিটেক্ট করতে পারে সিঙ্গেল বিট এরর। যদি কোনো ধরো 1110 পাঠালাম, এখন আমি কি বসাবো, সেই যে ডিটেক্ট করতে পারতেছে। তো আমাকে বলে দেওয়া হলো দিস ইজ ইভেন প্যারিটি। তো এখানে মেসেজের মধ্যে 3টা 1 আছে, তো আমি একটা এক্সট্রা 1 বসিয়ে দিলাম। এই যে আমি ডিটেক্ট করে বসিয়ে দিলাম, দিস ইজ কল্ড সিঙ্গেল বিট ডিটেক্টিং ইন কোড ওয়ার্ড। ওকে, আচ্ছা, এরপর আরো আছে ক্যান ডিটেক্ট অল অড নাম্বার অফ এররস অলসো 1357, এটা একটু পরে দেখছি আমরা। ইফ উই আর সেন্ডিং, এই যে ধরো 1101 প্যারিটি, এখানে কতগুলা 1 আছে দেখতে পাচ্ছি। এই কোড ওয়ার্ডটা লাস্টেও বসতে পারে, সামনের দিকেও বসতে পারে। তো এখানে আমি সামনের দিকে বসিয়েছি। তো এখানে যদি দেখো যে এখানে সেন্ড করেছি কি 111101, রিসিভ করেছি কি 01101, বাট প্যারিটি হচ্ছে এখানে আমি কি করেছি, প্যারিটি ইভেন পাঠিয়েছিলাম, দেখতে পাচ্ছ 4টা 1 ছিল, আমার রিসিভ হয়েছে কি অড রিসিভ হয়েছে। সো এরর ইজ দেয়ার, এটা প্রথম বিটেই আমার এরর এসে পড়ছে। আমরা এইভাবে এরর ডিটেক্ট করি। তারপরে এটা হচ্ছে এইটার কথা বলা হচ্ছে, ঠিক আছে। যদি একটা বিট এরর আসে সে এটা ডিটেক্ট করতে পারে, 3টা বিট এরর আসলে ডিটেক্ট করতে পারে, 5টা বিট এরর আসলে, 7টা বিট এরর আসলে এরা ডিটেক্ট করতে পারে। এখানে একটা বিট এরর আসছে। তারপর দেখো আবার এখানে কি আসে, 111001। তো এখানে কয়টা 1 ছিল স্যার? 4টা 1 ছিল, মানে ইভেন প্যারিটি ছিল। তো আমার রিসিভ হয়েছে কি, দেখুন প্রথম 3টা বিট ডিটেক্ট করতে, মানে 0 আসছে রিসিভার এন্ডে, তারপরে 01 আসছে। সো আমার এখানে কত আসছে স্যার? পাঠিয়েছিলাম ইভেন প্যারিটি, পেয়েছি আমরা অড প্যারিটি। ঘটনাটা বুঝতে পারছো? তো ঘটনা হচ্ছে এখানে আমরা একটা বিট এরর ডিটেক্ট করতে পেরেছি, এখানে 3টা বিট এরর ডিটেক্ট করতে পেরেছি, এভাবে 5 এবং 7ও পারবো। So when receiver will count, it will detect that number of ones in the data word is 0. Data word এর মধ্যে number of ones হচ্ছে 0. So parity should be 0. In this way it will recognize some error is there. So এইভাবে আমরা detect error করে data link layer. So একটা বিট, 3টা বিট, 5টা বিট, 7টা বিট এরর ডিটেক্ট করতে পারে কিসের মাধ্যমে? প্যারিটি, ইভেন প্যারিটির মাধ্যমে ডিটেক্ট করতে পারে এইভাবে। আচ্ছা, হ্যামিং ডিসটেন্স আছে, হ্যামিং ডিসটেন্স একটু পরে আসছি, আমি আগে একটা ভিডিও প্লে করে নিই।
The cyclic redundancy check CRC. In part 1, we will be focusing on the sender side, that is the CRC generation. Let's start the session with the outcomes. What we are going to learn in today's session. In today's session, we are going to know the types of error detection and we are going to understand how to generate the CRC. The generation of CRC is mainly the responsibility of the sender. Let's start the session by knowing the types of error detection. We have basically 4 error detection methods. In the previous lectures, we have discussed VRC, LRC and checksum. The final error detection method is the CRC, that is the cyclic redundancy check. And we know that any error detection technique, we are going to append the redundant bits in the message, because this redundant bit only will enable the receiver to detect whether there is an error or not. So likewise, CRC is also going to generate some bits, and these bits are called as the redundant bits. And in this technique, these redundant bits are specifically called as CRC. Let's solve a problem now. Find the CRC for the data block 100,100 with the divisor 1101. The protocols that the sender and the receiver mutually agree upon will decide the divisor. So the divisor will be known to the sender and the receiver. So based on the divisor, the CRC is going to be calculated, or the CRC is going to be generated in the sender side and verified in the receiver side. Now for time being, let's assume the divisor is 1101 and we are given with the data block, that is 100,100. Let's look at the generation of CRC in the sender side formally. The CRC generation at the sender side involves 4 steps basically. Step number 1, find the length of the divisor and we are naming it as L. And after finding the length of the divisor, in step number 2, we are going to append L-1 bits to the original message. Suppose if the length of the divisor is 5, then we are going to append 4 bits to the original message. Don't get confused. This appending 4 bits to the original message is not the CRC. For doing the operation, we are going to append L-1 bits to the original message. And then perform binary division operation. So we have a divisor and we have a message that is appended with L-1 bits. Now let's start performing the binary division. After performing the binary division, we will get 2 results. One is the quotient, another one is the remainder. Then whatever we get as the remainder, that's the CRC. And please note, we are appending L-1 bits, so the L-1 bits must be the CRC code. Suppose if we are appending 4 zeros, then 4 bits must be the CRC bits. And when we want to perform the binary division operation, we must be knowing about the exclusive OR operation. So we will just have a recapture on exclusive OR operation. A and B are the 2 variables. So the possibilities for A and B in binaries are 00, 01, 10 and 11. we are gonna perform A XOR B, that is A exclusive OR with B. So for same inputs, it won't produce any output. So for 0, 0 and 1, 1, there will be 0 output. For different inputs, we will get 1 as the output. So this is the logic behind exclusive OR. You may be wondering, we are actually going to perform binary division operation only. What is the need for knowing about exclusive OR? You will understand the significance of exclusive OR when we see an example. Let's see an example. In the question, message is given and the divisor is given. Just in the binary division operation, just place the divisor here and the message here. What is this part? This is the divisor. And what is this part? This is the message. On top of this, we will be getting the quotient. At the bottom, we will be getting the remainder. Now, step number 1, just recall step number 1. How many number of bits are there in the divisor? We have 4 bits. So L is equal to 4 here. So L is equal to 4 means how many zeros we are going to append? L minus 1, that is 3 zeros are appended to the message. So this is our message and 3 zeros we are appending with the message. After appending the zeros, let's start the binary division. How many times it is going to divide? 1 time. 1101 1 times is 1101. Now let's start the division. Actually, polynomial division, this binary division involves exclusive OR operation, and that's why in the previous slide, I just recaptured the exclusive OR operation. For same input 1, 1, we'll be getting 0. For same input 0, 0, we'll be getting 0. For different input, we'll be getting 1, and we'll be ignoring this. Anyway, it has no role to play in the operation. So the answer for this is same input 0, 0, different input 1. We will ignore this. Then the division involves bringing the next bit. So the next bit is brought here. Now how many times 1101 will be dividing this? 1 time. 1101 1 times is 1101. Let's perform the exclusive OR operation. This is going to be 1, 0, 1, 0. And we'll be ignoring this and we'll be getting 101. Let's bring this bit here. Now when we bring this bit here, how many times 1101 takes? It takes 1 time. When we do the exclusive OR operation and we get 111 because for different inputs we'll be getting 1. Now let's bring the next bit. How many times? 1 time. 1101. Now the answer is 0, 1, 1. Yes. As usual, let's bring the next bit. Now we are required to use the number of times it is dividing. But when we observe here, this is starting with 0. Anyway, this has no role, but this is 0. This is starting with 0. So we'll be putting a 0. Now when we divide, it is going to be 1, 1, 0. And bring the next bit. Divide it 1 times and we'll be getting 1101. And finally, we are getting the remainder as 001. And what is that 001? It is actually the remainder. In fact, in CRC, this is the CRC code. So this CRC code only is going to be appended with the original message. Now let's see what's the CRC. 001 is the CRC. Let's check it out. Yes, 001 is the CRC. And what is the actual message? It's 100 and 100. And this CRC is going to be appended with the message. Just see 100, 100. This is what the actual message. And we are appending 001. This is the data part. That is the original message. What is the other part? This is the CRC part. So the actual data that is transmitted is 100, 100, 001. And that's it, guys. There is a homework problem for you. Just try this. Find the CRC.
You're counting down the seconds until you can skip the ad, right? I get it. But what if you never had to watch that again? What if you had...
In part 1 of the CRC, we have seen how sender creates the CRC. In part 2 of the cyclic redundancy check, we will see how the receiver detects the errors using the CRC technique. Let's start the session with outcomes. In today's session, we are going to understand how the receiver detects the error using CRC technique. Let's take the same example what we have taken in the previous lecture. In the previous lecture, we took this example with the data block 100 and 100 with the divisor 1101. And we solved the problem using polynomial long division and we found out that the CRC is 001 and the data that is transmitted is 100100001. So where 1001000 is the actual data and 001 is the CRC, and this is what the message that is transmitted. Now let's say this transmitted message is received by the receiver without any transmission errors. It means this is what the information that is transmitted. Let the same data be received by the receiver without transmission errors. Now we will be focusing on how the receiver comes to know that there are no errors in the transmission. So to do this, what the receiver does, he takes the data what he has received. So this is what the data that he has received, and this is what the divisor. As I already mentioned in the previous lecture that the divisor is common for both the sender and the receiver. The protocol decides the divisor. And normally this divisor will be a polynomial expression. There are standard polynomials. I have taken 1101 as the divisor. In the previous lecture, the CRC was created with this divisor only, and hence the same divisor must be used by the receiver in order to detect whether there is an error or not. To do this, the same polynomial division, whatever the receiver receives, just put it here and the divisor here. As usual, the same polynomial division. 1101 1 times 1101. And just divide. Let's ignore this part. When we do this division, for same input it will be 0. For same input here also 0. And for different input it will be 1 because XOR operation we are performing. So the answer for this is 100. So it is 100. And let's bring the next bit. So 0 will take this place. Again we will divide 1101 1 times. It's 1101. And the result is 101. Let's bring the next bit. That is 0 here. Again 1101 1 time. It's 1101. And the intermediate result is 111. Let's bring the next bit. It's 0 and 1 time. It's 1101. And the result here is 011. Let's bring the next 0 here. Now if you observe, it's starting with 0, so we are required to use a 0 and bring the next one. And I'll simplify this problem by just putting 0 at the top and bringing the next digit 1 and doing the same operation. 1101 1 times, it's 1101, and the final result is 0. When the receiver gets all zeros as the remainder, the receiver understands that there are no transmission errors, and the receiver accepts the data what it was sent. And this is how the receiver concludes that there are no errors during transmission. I hope now you are clear with how the receiver detects the error. If we get a non-zero value here, it means there are errors in the transmission. To understand things better, I recommend you to solve the homework problem. Just take this homework problem. Suppose we want to transmit the message 11001001 and we want to protect it from errors using the CRC polynomial, and the polynomial expression is given, that is x cubed plus 1. Use the polynomial long division to determine the message that should be transmitted. So sender have to create the CRC and append that CRC with this message and transmit that message. When the receiver gets this message and the CRC without any errors, when he does the same polynomial division, the remainder will be obviously 0. It means there are no transmission errors. But the question is not complete. Just see this carefully. Corrupt the leftmost third bit of the transmitted message. That is, if this is the message, the leftmost third bit, this is the left hand side, and the leftmost third bit should be corrupted. It means when we see 1 here, it should become 0, or if we see 0 here, it must be 1. So in this case, 0 will be made as 1. So deliberately corrupt the leftmost third bit of the transmitted message and show that the error is detected by the receiver using CRC technique. After you deliberately make the error in the transmitted message, the receiver does the same polynomial long division operation, but the remainder of that operation done by the receiver will not be 0. If the remainder of the division performed by the receiver is a non-zero value, obviously there are errors. And that's it about the CRC technique.
ওকে, আমরা সিআরসি দেখলাম, এখন আমরা দেখবো চেকসাম টেকনিকটা দেখবো। তিনটা টেকনিক, তিনটার মধ্যে একটা দেখলাম, আরেকটা এখন বাকি আছে, আরেকটা বাকি আছে।
Now we will see the checksum. Let's start the session with the outcomes. In today's session, we are going to learn and understand the checksum and its performance. And we know very well that the third error detection mechanism that we are addressing is the checksum. Let's start the session with what is a checksum. The name itself says that checksum means it is going to check the sum. So the sender is going to create the message, and with the message, it is going to calculate the checksum and it is going to attach the checksum to the message. How this checksum is going to be created and how it is going to be validated, that we are going to address in today's lecture. So obviously, in the sender side, the checksum is created, and in the receiver side, the checksum is validated. So after validation, if the receiver finds out that there are no errors, then the packet is accepted or the data is accepted. Otherwise, the data is rejected. Let's see how this checksum is created in the sender side. The operation of creating the checksum in the sender side involves 4 steps. Step number 1. Break the original message into k number of blocks with n bits in each block. For example, if we have 20 bits and we want 4 blocks, so we will have 20 bits in 4 blocks where 5 bits in each block. That is what this point is all about. So breaking the original message into k number of blocks where in each block we have n bits. And step number 2 is we are going to sum all the k data blocks. We know in the previous step we have broken the original message into k number of blocks and we are going to add or sum all the k number of blocks. The summation sometimes may generate a carry, and add the carry to the sum if any such carry is generated. And the last step is just to do one's complement to the sum. Whatever we get after performing the one's complement, that is called as the checksum. So the checksum will also be of n bits. Every block of data is of n bits and the checksum will also be of n bits. So basically the operation at the sender side involves 4 steps, and we have seen all the 4 steps in points. Now let's look at the operation diagrammatically. The original data is broken into k number of blocks or sections where each block is of n bits. This is step number 1. And in step number 2, we are going to sum all the sections, that is all the n bits. After adding all the blocks, we will get n bits only as the sum. In case if it generates a carry, just add that carry to the sum and we will again get n bits only. After getting n bits, just do one's complement, and whatever we get after performing one's complement is the checksum. We know that this checksum will also be of n bits. And we know this is the original message and this is what the checksum that we have created. Now all the bits or all the sections are sent to the receiver. At the last we will be appending the checksum. We know this is section 1, section 2 up to k sections. This is section 1, section 2 up to k sections. And finally we are appending the checksum. And what the receiver does? Very simple. The receiver collects all the sections and it also collects the checksum and just performs the sum or the addition. If the result of the addition is, if it is all ones, the receiver accepts it. Otherwise, it rejects the data packet it has received because there are transmission errors. Let's understand the checksum's operation with an example. Let's consider the data unit to be transmitted is this one. Now we know step number 1 is breaking the message into blocks. So we are breaking this original message into 4 blocks, 1, 2, 3, 4, and each block has 8 bits. Up to this is block 1, up to this is block 2, here is block 3, and here is block 4. Now let's see what the sender does. We know the sender only has created these 4 blocks. The sender places all the 4 blocks in order to perform the addition. Just see, this is block 1, this is block 2, this is block 3, and this is block 4. And what the sender does? The sender have to perform the addition. So the sender is now performing the binary addition. 0 plus 1 is 1. So no carry is generated. The result is 1 and no carry. And here 0, 0, 1, 0. The addition is 1 and no carry. 1 plus 1 is 1, 0. It's binary addition. 1 plus 1 is 1, 0. 1, 0 plus 0 is 1, 0. And 1, 0 plus 0 is 1, 0. So here we get 0 and a carry as 1. So 0. And we take that 1 to the next column. This 1 is the carry here. Now just add this carry to this column. Now we will get 1, 0. So 0 we are placing here and 1 as the carry here. Now just add 1 plus 1 is 1 0. So we are placing 0 here and 1 as the carry. 1 plus 1 plus 1 is 1 1. So 1 here and 1 as the carry. 1 plus 1 is 1 0. So 0 here and 1 as the carry. 1 plus 1 plus 1 plus 1 is 1 double 0. So 0 here and 1 0 is the actual carry. And we know that if we get a carry, that has to be wrapped around. It means that has to be added to the sum what we have got. So just bring this 1 0 here. So what I am doing? Just bringing this 1 0 to the result. Again you perform the addition operation. So 1 0 is 1. 1 1 is 1 0. So 0 here and 1 here. We have 1 here and that 1 is brought here and the other things are kept unchanged. Now we got the summation with carry. After we do the sum, we are required to do the ones complement. Now let's perform the ones complement. Ones complement means changing ones to zeros and zeros to ones. So in this case, this 1 is becoming 0, this 0 is becoming 1, 1 is becoming 0, 0 is becoming 1, and we are performing the ones complement. After we perform the ones complement, whatever we have is the checksum value. Now we got the checksum. What the sender does? This is the checksum. This checksum value is appended with the message. Now if you notice here, this is the actual message and the checksum is appended with the message. Now this is sent to the receiver. What the sender does? It creates the checksum with the data block. It appends the checksum. Now this value is sent to the receiver. So sender part is over because sender for the message it has created the checksum. Now it is the responsibility of the receiver to know whether there are errors or not. Now comes the receiver's turn. What receiver does? It collects all the data blocks including the checksum and the receiver sums all the data blocks and the checksum, and if the result is all ones, it accepts. Otherwise, it rejects. Let's see it with the same example. This is what the data block that the sender has sent. Let's assume that the receiver is receiving the same data block without errors. Now the receiver is receiving everything and this is the checksum. And if you notice here, this is the checksum. And all these data blocks are just placed here in order to perform the addition. Now to perform the addition, just do binary addition and we get the result. Here 1, no carry. Here 1 plus 1 is 1 0, so 0 here and the carry is 1. 1 1 1 is 1 1, so 1 here and carry 1. 1 1, again 1 1, again 1 1, again 1 1. The binary addition of 1 plus 1 plus 1 plus 1 plus 1 is 1 0 1. So we are going to place 1 here and the carry is 1 0. We know that if any carry is generated, we have to wrap it around. So 1 0 is brought, again the addition is performed, and now you can notice the addition. And if we get the result as all ones, the receiver accepts it. Because the result is all ones and the receiver understands that there are no transmission errors. That's it about the checksum. Let's now analyze the performance of checksum. Basically, this checksum is a very powerful technique because it can detect all errors involving odd number of bits as well as it can detect most errors involving an even number of bits. So it is powerful to some extent in detecting bit errors as well as burst errors. But the main problem is, if one or more bits of a segment are damaged and the corresponding bit or bits of the opposite value in the second segment are also damaged, then the sum of these columns will not change. If the sum of the columns are not changed, the receiver will not detect the errors. Simply, if the errors involving that there is no change in the summation, then the checksum technique will not detect the errors. That's the drawback. And that's it, guys. So far we have seen how to generate the checksum value in the sender side and how the checksum is validated in the receiver side. I hope you guys have enjoyed the session and thank you for watching.
Okay, just a minute. I'm coming back. সেটা হচ্ছে সাইক্লিক রিডান্ডেন্সি চেক, সিআরসি এবং চেকসাম। আর আরেকটা দেখলাম সিঙ্গেল প্যারিটি বিট। ঠিক আছে, তো এখানে আমি বলেছিলাম ফার্স্টে যে 3টা এরর ডিটেকশন আছে। আর আরেকটা হচ্ছে যেটা আমি এখন যাচ্ছি সেটা হচ্ছে হ্যামিং ডিস্টেন্স, এটা হচ্ছে চতুর্থ অপশন। এই 4টাই আপনাদের লাগবে আপনাদের ডেটা লিঙ্ক ক্লিয়ারের অপশনে। আচ্ছা, সাপোজ আমাদের 4 বিট ডেটা ওয়ার্ডস আছে, তো ভ্যালিড কোড ওয়ার্ড কি হতে পারে? 00 এভাবে মানে হচ্ছে মানে 4টা 0 থেকে 4টা 1 পর্যন্ত সাজিয়েছি। এইখান থেকে 4টা 0 থেকে 4টা 1 পর্যন্ত সাজিয়েছি এবং প্রত্যেকের সাথে আইদার 0 দিয়েছি অথবা 1 দিয়েছি টু মেক ইট ইভেন প্যারিটি। দেখো কিভাবে করেছি, এখানে এটা 1 পেয়েছি, এটা রেড কালারের লেখা, হোপফুলি এটা ফাইন্ড আউট করতে পারছো। একটা 1 ছিল, এখানে আরেকটা 1 বানানো হয়েছে, এই যে একটা 1 আর একটা 1, দুইটা 1 থাকলে 0, দুইটা 1 থাকলে 0, দুইটা 1 থাকলে 0, দুইটা 1 থাকলে 0, তিনটা 1 থাকলে আরেকটা 1 টু মেক ইট 4, একটা 1 থাকলে আরেকটা 1 বানাবো, দুইটা 1, দুইটা 1, দুইটা 1, তিনটা 1 ছিল আরেকটা 1 দিলাম রেড কালারের, তো তিনটা 1 ছিল আর একটা রেড কালারের 1, চারটা 1 ছিল 0। এটা হচ্ছে আমার ভ্যালিড কোড ওয়ার্ড। ওকে, হ্যামিং ডিস্টেন্সে ঘটনা কি হচ্ছে? সাপোজ আমরা 000 আছে।
স্যার আপনার স্ক্রিন শেয়ার হয় না স্যার।
ওহো, আচ্ছা, আমি যেটা পড়তেছিলাম হ্যামিং ডিস্টেন্স, সাপোজ উই হ্যাভ 4 বিট ডেটা ওয়ার্ডস, 4টা 0 থেকে আমরা 4টা 1 পর্যন্ত সাজাতে পারি 4 বিট ডেটা ওয়ার্ডের জন্য, 4 বিটের জন্য। এখন 4 বিটের ইভেন প্যারিটি আমরা যে বারবার পড়ছি, তো এখানে যেটা হচ্ছে 4টা 0 থাকলে একটা মানে আরেকটা 0 দিয়ে দিব, মানে কোনো 1ই থাকলো না, বাট একটা 1 থাকলে দুইটা 1 বানিয়ে ফেলবো আমরা। এই যে এখানে দেখো স্যার, এক 0-এর বেলায় রেয়ার কেন? 0কে ইভেন ধরা হয়, ঠিক আছে, 0 2 4 ইভেন ধরা হয়, 6 এভাবে, কারণ এখান থেকে আমরা 1 3 5 7 এভাবে কাউন্ট করি। 0010 0011 0100 এরকম কথাবার্তা এখন আসতেছে। ঠিক আছে, মানে হচ্ছে একটা 1 থাকলে এই যে এই কলামটা, স্যার এই কলামটা হচ্ছে আমার এক্সট্রা যে বিট বসাচ্ছি সেটা, এটা ডান পাশেরটা। ঠিক আছে, তো এই যে একটা 1 আছে আর একটা 1 বসালাম, একটা দুইটা 1 আছে আর কোনো 1 বসালাম না, মানে ইভেন প্যারিটি বানানোর জন্য। ঠিক আছে, তো 4 বিট কোড ওয়ার্ডের সাথে আমরা m+1 আর একটা অ্যাড করছি। এখন কোশ্চেন হচ্ছে যে সাপোজ আমাদের 4টা 0 আছে, তারপরে 4টা 1 আমাকে পাঠানো, মানে 4টা 1 আমি রিসিভ করলাম, পাঠিয়েছি 0000, তাহলে 1111 আমি রিসিভ করেছি, তাহলে তো পুরোটাই ভুল। তাহলে হ্যামিং ডিস্টেন্স কি হবে? হ্যামিং ডিস্টেন্স বলতেছে যে বিটগুলোর মধ্যে XOR অপারেশন হবে, মানে হচ্ছে সেন্ড করলাম 0, রিসিভ করলাম 0, তাহলে সেম হলে কি হয়? সেম হলে XOR এ 1 বসে, তো আমরা যেটা করবো XNOR করব। XNOR যেটা হচ্ছে সেম হলে 0 বসবে, সেম না হলে 1 0 যদি হয় বা 0 1 যদি হয় তাহলে 1 বসবে। ঠিক আছে, এটা XNOR এর। তাহলে হ্যামিং ডিস্টেন্স এখানে কি হচ্ছে? বিটগুলোর মধ্যে কম্প্যারিজনের পর 0 পাঠিয়েছিলাম, 1 পাচ্ছি, 0 1 0 1 0 1, তাহলে 4টা 1 পেলাম। হ্যামিং ডিস্টেন্স এখানে কত? 4। 4 কেন? 4টা বিট যেহেতু আছে এভাবে। আচ্ছা, XNOR না XOR? XOR XNOR এর ট্রুথ টেবিলটা মনে পড়ছে না, আমি কি ঠিক বলছি? নাকি তোমরাও ভুলে গেছো? ওকে, যাই হোক, তারপরে আমরা যদি আগাই, সেম ভ্যালু হলে 0, অপোজিট ভ্যালু হলে 1, ঠিক আছে? তাহলে সেম ভ্যালু হলে 0 বসবে, এখানে সেম ভ্যালু হয়নি 1, সেম ভ্যালু হয়নি 1, সেম ভ্যালু হয়েছে 0, সেম ভ্যালু হয়নি 1, তাহলে হ্যামিং ডিস্টেন্স এখানে কত? 3। মিনিমাম হ্যামিং ডিস্টেন্স শুড বি 2 সবসময় ফ্রম দ্য ভ্যালিড কোড ওয়ার্ড লিস্ট। কিভাবে বের করতেছে এখানে বলছে, দাঁড়াও একটু বলছে। মিনিমাম হ্যামিং ডিস্টেন্স শুড বি 2 ফ্রম দ্য ভ্যালিড কোড ওয়ার্ড লিস্ট। ভ্যালিড কোড ওয়ার্ড লিস্টে এটা আসছে। হ্যামিং ডিস্টেন্স 2 মানে হচ্ছে কি স্যার? মানে দুইটা ডেটায়, মানে দুইটা বিটে এরর থাকে মিনিমাম, তাহলে ফাইন্ড আউট হবে, একটা হলে হবে না, ঠিক আছে? কেন হবে না এখানে বলা হচ্ছে। সো দ্য ভ্যালিড কোড ওয়ার্ড লিস্ট, এটাও আমি বলে দিচ্ছি একটু পরে। সো দ্য ভ্যালিড কোড ওয়ার্ড লিস্ট, এখান থেকে দ্য রিসিভার ক্যান নট ডিটেক্ট d-1 errors where minimum having distance d equals to 2. So d-1 to -1, that means e1 hole, therefore if one bit is changed in the valid code word, it can be detected by the receiver. একটা বিট যদি চেঞ্জ হয়, রিসিভার এটা ডিটেক্ট করতে পারে না, ঠিক আছে? কিভাবে পারে না, এখানে সেই কথাটা আমি তুলে ধরছি। সেটা হচ্ছে, ফাঁকা জায়গা পাই, 0001 পাঠিয়েছি, ঠিক আছে? আমি পেলাম কি 001, এখানে আমি আর একটা বিট অ্যাড করছি ইভেন্ট প্যারিটির জন্য 1, তাহলে আবার পাঠালাম। ধর আমি এটা সেন্ড করেছি, এখন এটা রিসিভ করছি 01011। তাহলে আমি যদি দেখি, এটা যদি দেখি এটা কি আসছে, 010, সেম বিট থাকলে 0, সেম বিট থাকলে 0, এই একটা হ্যামিং ডিস্টেন্স আসছে আমার এটা। তাহলে এটা ভ্যালিড না কেন স্যার? ভ্যালিড না এই কারণে, এই যে 5টা ডিজিট যে দেখতে পাচ্ছ কম্বিনেশন 01000, এই 5টা 1 এর, মানে 5টা ডিজিটের কম্বিনেশন কি তুমি এই লিস্টে খুঁজে পাও? দেখো তো, আমার এটা বের হয়েছে কি 01000 হ্যামিং ডিস্টেন্স হয়েছে। এটা কি আমাদের এই যে ভ্যালিড কোড ওয়ার্ড লিস্টে আছে? দেখতে পাচ্ছ আছে? নাই, খুঁজে দেখো, পাবা না। সবচেয়ে কাছাকাছি গিয়েছে এইটা 01001 লাস্টে চলে আসছে। এই জন্য বলা হচ্ছে যে দুইটা বিট যদি হ্যামিং ডিস্টেন্স যদি 2 আসে, তাহলে রিসিভার ওটা রিসিভ করতে পারে, মানে ডিটেক্ট করতে পারে। ডিটেক্টের কথা বলতে পারছি, রিসিভ করবার পর ডিটেক্ট করতে পারে যে there is a error। বাট একটা বিট এরর হলে সেটা রিসিভ হয়ে যায়, ওইটার ক্ষেত্রে রিসিভার ডিটেক্ট করতে পারে না। এটাই হচ্ছে আমাদের হ্যামিং ডিস্টেন্স। আরেকটা এক্সাম্পল করি, দিস ক্যান কাম টু ইউর এক্সাম। ধরো সেন্ড করেছি 11101 পাঠিয়েছি, 5টা বিট, ঠিক আছে? রিসিভ করছি কি, এখানে দেখো ভ্যালিড নাকি দেখতে হবে, 4টা 1 আছে, ওকে। দেখি আমরা একটা ডিজিট নষ্ট হয়ে গিয়েছে, একটা ডিজিট বা একটা বিট করাপ্টেড হয়ে গেছে। তাহলে আমার এখানে কত আসবে? 1, বাকি সবগুলো এটা মিসম্যাচ হলে 1, বিট যদি ম্যাচ করে তাহলে 0, ওকে? এটা আসলে রেজাল্ট। এখন এইটা কি আমার 1 4টা 0, 1 4টা 0 কি আমার এই যে ভ্যালিড কোড ওয়ার্ড লিস্টে আছে? নাই। এই যে দেখো সবচেয়ে কাছাকাছি আছে 10001, ঠিক আছে? ভ্যালিড কোড ওয়ার্ড লিস্টে নাই। দ্যাট ইজ ওয়াই এই একটা বিটের যে সমস্যা, এটা রিসিভার এন্ডে ডিটেক্ট করতে পারে না রিসিভার। এই কথাটা হ্যামিং ডিস্টেন্সে বলা হয়েছে যে ক্যানট ডিটেক্ট d-1 এরর্স, ঠিক আছে? তো সিআরসি দেখলাম, চেকসাম দেখলাম এবং প্যারিটি বিটস দেখলাম, তিনটা দেখলাম। আর প্যারিটি বিটস এর মধ্যে বেসিক্যালি হ্যামিং ডিসটেন্স পড়ে। ঠিক আছে, আচ্ছা এখন কিছু জিনিস বাদ দেখে আসছিলাম নেটওয়ার্ক ফিজিক্যাল লেয়ারে, সেটা আজকে একটু দেখবো। সেটা হচ্ছে ডিএইচসিপি, তারপরে পাবলিক প্রাইভেট অ্যাড্রেস, এগুলো মজার, এগুলা ম্যাথমেটিক্যাল কম্পিউটেশন নাই, এগুলো হচ্ছে ডিভাইস সম্পর্কে ধারণা। ঠিক আছে, বাট দিজ আর অলসো ইম্পর্টেন্ট ফর ইউর এক্সাম। ভিডিও প্লে করছি।
Modem and a router, because a lot of people actually think that a modem and a router are the same thing, but they are not. They are different with two separate roles on a network. So I'm going to explain the difference between the two. Now, if you want internet inside your home or business, you have to have a modem. A modem is what brings the internet into your home or business. A modem establishes and maintains a dedicated connection to your internet service provider to give you access to the internet. Now, the reason why you have to have a modem is because of the two different types of signals that are used on a computer and on the internet. A computer only reads digital signals, while signals out on the internet are analog. As analog data comes in from the internet, the modem demodulates the incoming analog signals into a digital signal so that a computer can understand it. And a modem also modulates outgoing digital signals from a computer into an analog signal as it goes out on the internet. And this is where we get the word modem. The word modem means modulator demodulator, which is exactly what a modem does. It modulates outgoing data from a computer and demodulates incoming data from the internet. Now, a router comes in after the modem. Now, there are different types of routers. There are routers that are used in businesses and larger organizations, and there are smaller routers that are used in homes and small businesses, but they basically do the same thing. But for this video, we're going to use the small office, home office router that most of us are familiar with. Now, a router is what routes or passes your internet connection to all of your devices in your home or business. It directs it to all of your computers, tablets, phones, and so on, so that those devices can access the internet. A typical small office, home office router, like this one here, will have a built-in switch with multiple ports so that you can connect multiple devices using an Ethernet cable connection. And it also functions as a wireless access point so that wireless devices, such as tablets and laptops, can have internet access. Now, technically, you really don't need a router if you only want one of your devices to access the internet. You can just plug that device's network cable directly into the modem, and then you'll be able to access the internet. However, like most homes and businesses, you're going to have multiple devices that need access to the internet, and that's where you would need a router. There are also different types of modems. Two of the most common types are cable and DSL modems. So depending upon what type of internet you're going to use, you need to use the correct type of modem. Cable modems are connected to your home using a coaxial cable. Cable is typically provided by the same company that provides you with cable television, such as Comcast, which is one of the largest providers in the United States. And DSL modems are connected using a typical phone line. DSL is provided by companies such as AT&T, which is the largest provider in the US. Now, a lot of times, your internet service provider, when they send you a modem, or if you were to buy one at the store, the modem might be a modem-router combination. So it will be a modem with a built-in wireless router in one physical device, such as this one here. So here is an example of several different networks on how they connect to the internet. For example, this network here on the left is using a cable modem, and it's using a small office home office router so that its computers and the tablet can have internet access. On the bottom we have another network, and this network is using a DSL modem, and it's also using a small office home office router so that its computers, the laptop, and the tablet can access the internet. The network here on the right is an example of a business network, and it's using a cable modem, and it's using a business router so it can connect its computers and its server. And finally, we have the network here on top, and this only has one device that needs internet access. So it doesn't need to use a router. It can just directly connect to the modem because only one device needs internet access. Now, if you're wondering how hubs and switches relate to routers and modems, especially if you saw my other video where I explained the differences between hubs, switches, and routers, well, keep in mind that most routers will have a built-in switch inside of them. So there's no need to have a switch if you already have a router that has a switch built into it. So for example, a router like this may have a 4-port integrated switch so that you can connect 4 Ethernet cables for your wired devices. So the only time that you may need to add a switch to this network is if you needed more wired connections for your devices. So you can just connect a switch to your router and then add more connections to the switch. So just to clear things up even more, over here we have the internet with all of its routers. Then as the internet is routed into this private network, it first reaches the modem. Then it goes from the modem to its router with its integrated switch, and then it's passed to all of its computers.
ভিডিওটার সাউন্ড আসছিল না, আবার প্লেব্যাক করছি। আচ্ছা, আর দুইটা ভিডিও আছে, একটা হচ্ছে ম্যাক অ্যাড্রেসের উপর, একটা হচ্ছে আইপি অ্যাড্রেসের উপরে, তাহলে আমাদের আজকের ক্লাস শেষ হবে।
So that is the topic of this video. Now the MAC, or Media Access Control Address, is an identifier that every network device uses to uniquely identify itself on a network. So no two devices anywhere in the world will have the same MAC address. The MAC address is made up of a 6-byte hexadecimal number that is burned into every NIC by its manufacturer. The MAC address can contain any number, and it also contains alphabets from A through F. The MAC address is broken up into 2 parts. The first 3 bytes identifies the manufacturer of the NIC, such as Linksys, Netgear, TP-Link, and so on. And the last 3 bytes are a unique number from the manufacturer that identifies each device on a network. The MAC address is also referred to as the physical address or hardware address. Now, MAC addresses are formatted in different ways. On a Windows computer, it will look like this, with dashes in between the digits. On Apple and Linux systems, it will have colons in between the digits. And Cisco will display the MAC address like this, where 4 sets of digits are separated by periods. So what exactly is the purpose of the MAC address? Well, the purpose of the MAC address is so network devices can communicate with each other. Whenever a device wants to talk to another device, it's ultimately done using the MAC address. And this is whether the devices are close to each other, such as being on the same network, or if they are thousands of miles apart on a different network. The bottom line is that devices communicate with each other using the MAC address. Now you might be asking yourself, well, if devices talk to each other using the MAC address, what is the purpose of an IP address? I mean, aren't IP addresses also unique? Well, public IP addresses are unique, but public and private IP addresses can periodically change. So you may have had a certain IP address for the past few months, but an internet service provider or a network administrator can change your IP to a different one. But MAC addresses don't change. They are permanent. Now, the way TCP/IP works, which is the language that's used on networks and the internet, a networking device needs both an IP address and a MAC address. The IP and MAC address work together so devices can talk to each other. So as I stated before, the MAC address is used to identify a device, but an IP address is used to locate that device. So for example, in a typical neighborhood, you have houses and you have people living in those houses. Each house has a mailing address and the person living inside has a name. An IP address is like the mailing address of the house. The mailing address tells us what country, city, and the street of where the house is located. But it doesn't necessarily tell us who lives in the house. But a MAC address is like the name of the person. It tells us who lives in the house. So an IP address tells us where a networking device is located, but a MAC address tells us specifically who the device is. So as I stated before, the MAC address is ultimately used when devices want to talk to each other. So here we have a local area network that you would find in a typical home or business. So let's say that computer A wanted to communicate with computer B on this local network. So computer A is going to inspect computer B's IP address to see if it's on the same network or not. So after inspection, computer A now knows that computer B is on the same network because the IP addresses are in the same group. So now, in order for communication to take place, computer A needs computer B's MAC address. And it finds this by sending out what's called an ARP, or Address Resolution Protocol broadcast. So it will broadcast to every device on its local network, asking computer B to identify itself by asking for its MAC address. Then once computer B tells computer A its MAC address, communication can finally take place. So in another scenario, what if 2 devices wanted to communicate with each other, but they were on different networks? So let's say that computer A wanted to go to google.com. Now, in order for computer A to go to google.com, it needs the MAC address for Google's web server. But the problem is it doesn't know what it is. So this is why it needs the IP address to get the web server's MAC address. So computer A will type in google.com in its web browser, and then DNS will change google.com into an IP address so computers can understand it. So computer A will inspect Google's IP address and realize that the IP is not in its local network because the IP address is not in the same group as its local network. So now computer A realizes that Google's IP address is on a different network. And since it's on a different network, it's going to forward that data to its default gateway, which is the router. And then it will let the router deal with it. So again, computer A will send out an ARP broadcast, and this time it will ask for the MAC address of the default gateway. Then once it has the MAC address, it will send the data to the default gateway. Then once the default gateway has the data, it will inspect Google's IP address and determine the best path for the data to reach the destination. So it will forward the data to the next router, but before it can forward the data, it also needs the next router's MAC address. So it's also going to do an ARP broadcast and ask for that router's MAC address. Then once it has it, it will forward the data. And then that router needs the MAC address of the next router, and so on. Then once the data reaches the final router in its path, that router needs the MAC address of Google's web server. And then once it has it, the data has reached its final destination. So as you can see, each time data is passed between a computer or a router, it uses the MAC address to forward the data at each step. So to summarize, the IP address is used to locate and get to the final destination, but the MAC address is used at each step on its way to the final destination. Now, if you want to find out the MAC address of a computer, this is how you do it. So on a Windows computer, you just open up a command prompt and type ipconfig/all. On Linux and Mac computers, you open up a terminal and then you type ifconfig. So here is the MAC address for this Windows computer. And as you can see, it's listed as the physical address. Now, a computer can have more than one MAC address. It just depends on how many network interfaces it has. So for example, this computer has 3 MAC addresses. There is one for the wired network adapter. This one here is for the wireless network adapter, and this one here is for the Bluetooth network adapter. Now, if you want to know more about this topic, I highly recommend you watch a couple of my other videos, such
লাস্ট ভিডিও প্লে করছে আইপি অ্যাড্রেসের উপরে।
everyone. In this video, we're going to be talking about the difference between public and private IP addresses. And to be specific, I'm going to be talking about IP version 4 addresses. So the first thing we have to know is, what is an IP address? Well, an IP address is a numeric address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. And there are 2 different types of IP addresses. There's public and private. So what are the differences between the two? So let's first talk about public IP addresses. Now, when you order internet service from an internet service provider, they are going to assign your modem or your router in your home or business a public IP address. This public IP address is registered on the internet. It's what gives you access to the World Wide Web. So if you don't have a public IP, you cannot access the internet. Public IP addresses are also unique. There are no duplicates anywhere in the world of public IP addresses. Now, when IP addresses were created, engineers didn't realize how big the internet would become. Because even though there are over 4 billion IP version 4 addresses available, the engineers thought that this would be enough. But they were obviously wrong because of the explosive growth of the internet. So in order to prevent a shortage of public IP version 4 addresses, engineers developed private IP addresses. Now, private IP addresses are not publicly registered on the internet, so you can't access the internet using a private IP address. However, if your device does have a private IP address and you want to access the internet, your private IP has to be converted into a public IP address before you can access the internet. And this is because private IP addresses are only used internally, such as inside a home or a business. They are not used out on the public internet. And a service that's inside your router called DHCP is what assigns your internal devices a private IP. So as an example, most homes and businesses are not going to have just one device that needs access to the internet. Chances are they're going to have multiple devices that need internet access. So all those devices need a public IP address if they want to access the internet. Now, you could contact your ISP and ask them for these additional IP addresses for all of your devices. But that's going to be more expensive, unnecessary, and more importantly, it'll be a waste of public IP addresses. And let's face it, if every device in the world had their own public IP address, we would have run out of public IP addresses already. So what we can do instead is we can have the router assign the devices inside our home or business private IP addresses. And when these devices need to access the internet, their private IP address will be translated to the one public IP address that we have been given. And the service that translates this is called NAT, or Network Address Translation. And it's a service that's built into our router. So not only does it translate private to public, but it also translates public to private. Because if a computer on the internet wants to communicate with a computer on this private network, the public IP address needs to be translated by NAT to the private IP address for that computer. Now, private IP addresses have 3 different classes, and these classes have different ranges. So Class A private IP starts with the node 10. This class is typically used for large organizations. Class B starts with 172. This is typically used in medium-sized organizations. And Class C will start with 192. This is used in small organizations or homes. Class C is the most popular range of private IP addresses that's used. So don't be surprised if you happen to check your IP addresses on your devices in your home if you see them starting with 192.168. Because like I said, it's the class that's mostly used. Now, if you want to find out what your IP address is, this is how you do it. If you're using a Windows computer, you just open up a command prompt and type ipconfig. On Mac and Linux computers, you just open up a terminal and type ifconfig. So here is the IP address for this computer. And as you can see, this is a Class C private IP address that has been given to us by our router. So since this computer is assigned a private IP, it's not going to show our public IP. But if you want to know what your public IP address is, you just open up a web browser and then you will go to a website like whatsmyipaddress.com, and that web page will show you your public IP address. So to summarize, public IP addresses are unique, while private IP addresses are non-unique, because the same private IP addresses can be used in other private networks. Public IPs are publicly registered, so they are able to access the internet, while private IPs are not publicly registered, so they cannot access the internet directly. Public IPs are used externally on the internet, while private IPs are used internally on local networks. Public IPs are assigned by your internet service provider, while private IPs are assigned by your router. Public IPs are not free. You have to pay for them. But private IPs are free. As far as security, public IPs are not secure because they are used externally out on the internet, so they are traceable. So in order to make a public IP more secure, you have to add security measures, such as using a proxy or a VPN, which hides your public IP address. But private IP addresses are more secure because they are hidden from the internet. They cannot be traced outside of their own network because they are used internally. Now, even though
আচ্ছা, এই পর্যন্ত ছিল পাবলিক প্রাইভেট আইপি অ্যাড্রেস পর্যন্ত। হোপফুলি ইউ হ্যাভ আন্ডারস্টুড। তো আপনাদের রবিবার দিন আবার ক্লাস হবে। ইন দ্য মিন টাইম আপনাদের পোস্ট ল্যাব অ্যাসাইন করা হয়েছে। এই পোস্ট ল্যাবের ডেটা বাড়ানো হবে না, খেয়াল রাখবেন। যেতে পারেন। থ্যাংক ইউ।
আসসালামু আলাইকুম স্যার।